Hello and welcome to this lecture. This diagram represents the general diagram of zinc series. Zinc has two parts. One is called PS programmable processor system and other one is PL programmable logic part. In PL we have FPGA and in PS we have processor system, and in zinc we have ARM processor system. So in order to communicate between processor system and PL part, we need an interconnection, and this interconnection is called AXI interconnection block. In this lecture, I will teach you how we can connect our processor system with Uart and DDR3 Ram. So this is the general diagram of what I'm going to implement just a few minutes after. So we will implement this part. So let's open it. Now in this lab, the board which I am going to be used is Zybo board. Lab 1. Okay, next. So here we need to select the board on which we will do our programming. So Zybo is the board which is going to be used. Okay. So this is the overview of Vivado. Here what we need to do, our first step is to create block design. So leave it. You can change the name here. I don't like to change the name. Okay. In this part I have to select processor system. So just this is our processor system. This is our original, you can say, processor system, ARM processor system. This processor system make connection with the PL part, but in this lab we just need to connect this PS processor system with just DDR, RAM and Uart. So just double click on it. Okay. So this is the general diagram of processor system. If you will see here, this is PS part, processor system. In PS processor system, these are the modules which are present within PS part. And if you will see here, there is PL programmable logic part that is called FPGA, and we can connect our PS with PL through AXI interconnection. So PL as we just need to connect, sorry, before that I have to do something else. I have to do run block automation. Okay. So if you will see here, there are a lot of ports which are visible here, but we just need to DDR and Uart. So we have to remove all the other parts. So double click on it. click here, peripheral part. We don't need to connect that port, that port, that port, that port, that one. Just need Uart 1. If you will see here, there's no need of that one, and because we are just using PS part, so there is no need to connect PL with PS. That there is no need to connect this GPU interface is a interconnection between PS and PL part, because we are not going to use PL programmable logic, so we need to disconnect it from PS. Okay, next one is clock, because as we know we are not going to use PL part, so we need to disconnect the clock of PL. If you will come here, you can deselect here. After that, just click OK. So this is, if you will see here, we have just DDR and fixed IO. Here we have UART port. So just we need to verify as it is it have any mistake or not. If you will see here, there are no error or critical warning in this design. Okay, the next step is go here, click here, and just generate output products. After some time, you will see that box which shows that generation of output products completed successfully. Okay, next step is we need to generate a VHDL file or Verilog file that we will use in our processor system. Okay, we have that file here. Now we have done our job. We need to transfer. We have to debug our design whether it is working or not. So go here, export hardware. So just there is no, because bitstream it represents that we have hardware part, because we are not using programmable logic part, so there is no need to include bitstream here. But later on we will see in next lectures that we are going to use bitstream there, so we will see there. But here there is no need to use. Okay, yes, save. Okay, now launch SDK. You can say, you can write here C code to debug our hardware design software development kit. So just by writing C code, you can check whether your program is working correctly or not. After some time, you will see that SDK is opened, and after it is opened, you will see these bunch of files. This hardware file represents that you have different modules. If you will see here, DMA, GPIO, like that, DDR. These are the addresses for processor system. If you will see here, we have Cortex 9.0, and if you will go down, you will see Cortex 9.1. So in Zybo you have dual processor, Cortex 9.0 and Cortex 9.1, and by default all of our work will be done on Cortex 9.0. So here we need, if we will go to here we just need to check either our memory. We need to send data to memory and see our results through UART port, either it is working or not. Okay, the next part is to generate software file, application project. Write the name, let's testing, standalone. As you can see here, processor Cortex 9.0. Next, so memory test, because I'm going to test either my PS part is connected with DDR3 or not. If you will see here, after generating what I can say application project and generating a memory module, you will see here testing. If you will open it, you will see here source, and within source memory test source. So this is the auto generated code by you can say in order to test either our hardware, you can say module is working or not. So here we just need to test whether it is working or not. So now we need to connect our hardware, that is Zybo, with a computer. So I have connected with the computer. So next step is here you need to go terminal. You have to do some setting, because we are using UART. We have to do some setting. Okay, so it is connected. I have also connected my FPGA with the computer. So if I will right click here, debug, run as launch on hardware. It will take some time. Okay, if you will go to the here, you can easily observe that memory test application completed. Everything is verified here. If you will go into the code, if you will see print memory test application complete, if you will see here, this is what we are doing here. We are doing some testing on the memory. If this testing is passed, so this line will be printed. So it's mean our program is working. I hope that you will find some valuable information from this lecture. And goodbye, have a good day,